Awesome. Well, how about I just start? I have a little presentation. I'll keep it short. And let me share my screen. Everybody see that?
Yep.
Yep.
Yeah.
Okay, so this was a poster that was in probably every CAD office back in 1979, 1980. You can see over here in the upper right-hand corner that's what's called a B-spline curve, which was very, very high tech at the time. If you watch these old movies, they have a computer, they'd have like a B-spline surface on there. That was the epitome of high tech circa 1980. And then did the next slide go? I just want to make sure there's no
Yep.
latency. Yeah, so here's the 3 boxes of historical artifacts that I shipped to Bill. And the inspiration was my wife is like, would you get this crap out of the garage? And I'm like, hey, these are
Sure.
historical
Bill has
records.
room.
Yeah. So I saw this show about the Swedish death cleaning, where like the Swedes make sure they don't let strangers come and like clean up your mess after you're dead. So anyway, that was my inspiration of sending this stuff. And I just couldn't bear to throw it out. It's of use to somebody, I believe. And so I believe the rightful storage location is SPED. So I started in the Bechtel drawing office in 1980, and this is pretty much what it looked like. Big drafting tables all over the place, lots of telephones ringing, and that sort of stuff. A lot of noise, really difficult to concentrate. And this is the Bible, the Leasley Bible here. I didn't ship this to you, but this was every CAD manager had one of those on the shelf up there. And Mike Leasley was an English guy from Cambridge, and he was a VP of computer vision. And he kind of wrote the book on what to do with plant design CAD. And so the use cases, obviously P&IDs were kind of the first product to come on board, basically because you had symbol libraries. And a small thing, just being able to insert a valve in a line, that was like a big deal. I mean, that was difficult to do, to break a process line and put in a inline fitting. And P&IDs change a lot. They get modified. So, you had to copy, move, and edit. So the big breakthrough was to stretch, to stretch out and add a new piece of equipment in a P&ID and that sort of thing. And then a lot of these CAD systems, they came out of electrical design, and there was what was called a net list report, where on a schematic you could see what was connected to what. And so there was a lot of epic fails around intelligent P&IDs, because the net list for a P&ID is a lot more complicated than a net list for a printed circuit board. You can change size, you can change spec, you can change materials, you can recurse upon yourself. I have a bypass on a control valve and that sort of thing. So a lot of wasted effort trying to do net list reporting on P&IDs. So plot plans were another, that's a critical document back in the day, where you would place the various pieces of equipment, in the area. And the thing that CAD had going for it was you could use real world coordinates. You had absolute accuracy. You could, all these little milestones would be exactly at the datum point in the plant. And then you could plot at different scales. And then, of course, you could move things around. You could copy and stretch. Unfortunately, we did the first test of using plot plans at Bechtel, and the drawings were so big they would take an hour to load. We had to actually put these guys on the third shift, and they would like take a full hour to load the drawing up. And these guys would be like, just to move one thing would take like 20 minutes. And the poor plant design manager it was a New Zealand gas project, was ready to kill us, because it's just like, this is a simple thing. It could be done in an afternoon. And we were taking days and days and hours, to just generate this simple drawing. And back then, the plastic model was the standard of operation. And I worked with a guy that was missing his thumb. He cut it off in the bandsaw at the Bechtel office in London. And these were like very insular people, the model makers. These were giant things for Ras Tanura. The Ras Tanura model took up the whole 22nd floor of 50 Beale. I mean, it took up the entire floor, and they were used primarily for client training. And this is going to be a recurring theme through this talk, is that basically we felt it was impossible to do this on a computer. You know, the plastic model was it. There was a company called Engineering Model Associates. I think I gave you one of the catalogs. It was a company out of Clifton, New Jersey, where you would actually buy little valves and scale, I guess 1 to 100 scale of different types of pipe sizes and that sort of stuff and equipment. But basically, it was difficult or impossible to do this on a computer. And then you have the piping orthographics, the 2D plans and sections, also pretty much impossible to do on a CAD system. I mean, these are the most skilled designers and draftsmen, you know, in the company. And this was, probably, 25, 30% of the effort of the piping department was to create these 2D plan drawings. At Bechtel, most of these guys were English. You know, we had a whole group of refugees from England that did this work. Yeah. And then last, you have the piping isometrics. I mean, this is the business end. You know, this is the deliverable to fabricate the pipe spools. And then this is where you generate your material takeoff. There's a bill of material on the right-hand side. Now, we actually had proprietary mainframe software that did this back in 1980. And you can see here, ICI, Imperial Chemical Industries, they were one of the leaders. They had a product called IsoPEDAC, and that was the precursor to the product called Isogen, which is still being used today, I'm assuming. And basically, you had this coding language where you would type flange, gasket, 2 meters, blah, blah, blah. And like you would code these things on punch cards, if you believe it or not. And God forbid you drop the punch card deck, man, you have to start over and rekey all that thing in again, And the main purpose of this was actually to get the piping material takeoff, and then the isometric drawing was a byproduct. So I worked for a guy who was a contemporary of Bill's, Malcolm Hall. He was he was the chief computer engineer at Bechtel, and he was one of the developers of IsoPEDAC. And I guess the rules were a little bit more relaxed down there, because Bechtel came up with this product called Screen, which is pretty much IsoPEDAC. I don't know how. I guess they were lax on the intellectual property, but I think that's kind of a recurring theme that you'll see through some of the English software that they came out, like PDMS and PACE and that sort of stuff. So guys were able to recreate these systems, in different venues. I remember the big thing in 1982, if you can believe it or not, we had Entrex terminals where you could actually get rid of the punch card and actually just enter the coding language, into a computer terminal. That was a really big deal back in 1982. So the main vendors of what I call the turnkey era, from about 78 to about 1985, obviously Intergraph out of Huntsville, Alabama. It was originally M&S Computing. Jim Meadlock was the founder of that company. And the big distinguishing feature of that system was the dual screens. And that was like crack cocaine to a lot of the users. Because one of the difficulties at the time, if you had, Intergraph IGDS started in a mapping context. And so if you had a big map and you zoomed in, you would get lost. And so they would have the zoomed in section on one screen, and they would have the full expanse on the second screen, so you wouldn't get lost in the drawing. And that was very, very useful in mapping. And then so the B-spline curves, that was also one of the features that Intergraph developed for mapping.
If I can interject for a sec, I remember seeing these up at Syncrude. They had them in-house at the Syncrude oil sands site in 1980, 84, 85. Maybe 83, somewhere around there.
Yeah.
And, a whole room
full
of
that
these
job.
things, and the guys were just dreamers. Yeah.
Yeah. I bid on that project. We lost.
Oh.
Yeah, we had them at Menenco in the late 70s for PNIDs and plot plants.
Right.
Anyway, sorry to interrupt.
Yeah. No worries. And then so we had computer vision. That's where, Bill Beasley and I have shared history, the CADS 3 system. And, they had, several companies, in the plant design area that were using this system. They pretty much came out of printed circuit design. That was their expertise. And unlike Intergraph that used the DEC PDP-11, computer vision made their own CPU. And that was kind of their downfall, is that they couldn't keep up with the, the excellence in computer design. And then Calma, which bounced around and eventually got bought by GE. They had a product called DDM. Their client base was primarily like National Semiconductor and people doing integrated circuits. And they used the Data General Eclipse. So these were the primary vendors that were involved in the turnkey CAD era.
Well, if I could interject,
go ahead.
At the beginning of the Alsans project by Techman Engineering and Nova, it was a 3D system. It was pretty impressive at the time, beginning of the 80s.
There's actually a divergence that between Intergraph and Calma. I'm sorry, Calma and computer vision. Calma and computer vision were versions of Patrick Andretti's AD2000 software kernel, which he sold proprietary licenses over and over again to different vendors, and they went on to develop their products. Intergraph had a completely different approach. They had a proprietary server which would rapidly render maps on the screen, and that was their huge distinct advantage. Computer vision actually, their hardware was proprietary according to them, but it was actually a Nova computer that they were repurposing and claiming as their own proprietary thing. But that was their downfall, is the fact that they stayed proprietary for so many years. And and I remember this 300 megabyte disk drives at Brown and Root. We were buying those for $50,000 a piece and begging for more. I remember changing out those disks on a regular basis, those platters on a regular basis.
Yeah.
Go ahead.
Yeah. So back then, the standard deliverable was ink on Mylar because you had a blueprint machine. You had a blueprint machine on every floor, right? And so you had the Calcom pen plotter. We had a dedicated guy with the white coat. He looked like a scientist, and that's all he did was run the plotter. And like a big E-size drawing, that might take 45 minutes to do. And God forbid the pen runs out of ink or something else like that,
Yeah.
And then basically we were like a tourist attraction. Anytime, they would bring in, the sheiks from Saudi Arabia, they take them up to the computer room to watch the plotter go, because that was like really, really high tech. That was a high tech diversion, So I think the Versatech plotters came in like 83, and that was like a breakthrough, But the problem with the Versatech is you couldn't run that through a blueprint machine. So it created another problem, for us.
Yeah.
And then, as I said, my phone, I have 98 gigabytes on my phone right now, but we were working with 300 megabyte CDC disk drives. We'd continuously run out of space, and, the disk would get fragmented. And some idiot found this program like a check disk or a defrag and would look at give you a picture of the fragmentation status of the disk. And there would be a riot with the CAD guys, because the system would slow down and they would like demand that like you have to reformat the disk and stuff like that. Monday mornings after you reformatted the disk were like a horror show, because you'd be missing symbols, like vowels would be missing from drawings, and the title blocks wouldn't appear because we didn't have ways to like restore all the basic system software, to the thing. And, it wasn't like you had a thumb drive or, you'd have to use this tape drive. And like, just to take a drawing off, that might take 40 minutes, because you'd have to go all the way to the end of the tape to have space to put the new file on. Or if you had to restore a drawing from tape, if it was at the end of the tape, that might take 20 minutes to get that drawing restored, and then would slow down the system as well, And like when you'd we'd have to start the backup on like the night shift, to stop the system degradation. And back then, guys would be sitting around doing nothing. This is typical of the drawings. The guys would draw all these drawings about snails with the system hanging or the snail crashing into the wall. And in the computer vision days, we used to have to do a check pack of the software. You would do a check and a pack of the, to maintain the integrity of the database. And that would take like 20 minutes. So like the guys would finish their drawing and then they would sit there and they'd do a check back and just sit there for 20 minutes while it went through this error correction routine. So I had a guy that worked for me, Daryl, and he was able to use one of the alphanumeric terminals, and he'd write a little program that would like do check packs automatically. That was like a breakthrough until the Aramco auditors found this stuff and they're going, who's this guy DKD? We want more of him because he's operating like 10 computer terminals at a single time, And at that time, we were charging, this was the big debate between, are you a cost center or are you a profit center? So we were charging $35 a man hour to do CAD drafting and $35 a system hour. So like we're charging guys $35 an hour to run a check pack and that sort of thing. And then the other big issue at the time was open shop versus closed shop. So typically the CAD was run at, there was a window, you dropped the drawing off, it was like a black box. They had no idea what happened inside there. We had specially trained operators. Typically we got guys out of like the aerospace industry that knew the CAD systems. And so Malcolm made this big decision to actually put this stuff out into the projects. So we had to relocate the terminals. Instead of having all 5 terminals inside a closed area, we would put them on the different projects where they could be supervised by the project personnel and then staffed by project personnel. And so we had to go through a lot of software, hardware upgrades. I'm sure Bill might remember the horror show that was CADS 4. I think we were the first, Bechtel was the first organization to go from CAD 3 to CADS 4. Everybody else was looking to see who would do it. And, it wasn't like you had GitHub or, or software code libraries back in the day. The testing wasn't what you would expect. And like, once you converted, horrible. Yeah, you were stuck. You were stuck. You couldn't go back,
Right.
So, we had vector terminals that we converted to raster terminals. That was the big deal about CADS 4. So in addition, we were the first guys to test the 3D piping system. And once again, this poor New Zealand GTG project, they bore the brunt of it. And it was the most expensive 2 drawings ever produced in the history of mankind, I believe. We just did 2 lines going out to a flare. That was it. It was just a flare line, a 6-inch flare line. And that was like thousands and thousands of man hours. And I think we determined that it was just not suitable, for production. And then a big thing that we did is we made a very extensive user training program. We trained something like 300 engineers at the time to use the software because, the guys that we were getting out of Boeing and General Dynamics, they didn't know what a valve was. They had no idea, of what these engineering terminology that was used. So we kind of bootstrapped our own people, into using the system. So that was some of the issues that we had. So then going from, the computer vision failed to develop their own hardware, digital equipment by 1985, 1986, basically they owned the process industry. VAXs were everywhere. They were the number 2 largest computer vendor. They had a whole development ecosystem based around the VAX. So, there was all these third-party software developers that, would develop specific program for the VAX. And then Deck World at the time, I think it was the largest computer show outside of the Las Vegas, consumer electronics show. I went to the Deckville in Cannes. They had the Queen Mary out in the harbor. You would go out on the boat to Queen Mary. Ken Olson would wave to us from the little tender, as he'd come to dinner. They had the Chateau de Deckville. They had a white and they had a red, and they had the whole Palais de Congrès in Cannes for this crazy trade show. Unbelievable. And at that time, these specialized newsletters and trade shows began to come out. So the most famous was Ed Forrest, the AEC Automation newsletter. Ed was a manager at CF Braun, I believe. And like he used to have to pay like $150 a year for the subscriptions to these magazines, which is probably like $1,000 today, you know. And Ed did not have a negative word to say about anybody. Very, very positive. And so my story with Ed was, you know, I was a junior marketing guy at Pace, and like, you know, I put together all this material, you know, for him to do a article on the PACE system, the combustion engineering system. And basically Ed just printed the whole thing as is. And people couldn't believe it. They go, wow, look at this write-up. This is unbelievable. It went right up to the CEO of the company, Charlie Hugel at the time. He was like so impressed, you know, with the coverage that we got. You know, I didn't tell anybody that he just took what we gave him and just printed it, you know. And then another guy was David Weisberg. So, you know, Bill has a lot of inside, you know, track on the CAD software, but Weisberg, he worked at Auditrol for a bunch of years, and he ended up writing his own engineering automation report. There's a link to it here. He's got like a lot of details of the different systems like Integraph and Calma and stuff. If you want to do some research, this is a good place to go. Another guy was Steve Wolf, who had the computer-aided design report. But what this created, you had all these experts like Carl Matchover and, you know, Steve Wolf. And so basically you had this whole professional benchmark industry, you know, so benchmarking became like a big deal, you know. And so we had the AEC Systems trade show. That was like the be all and end all place. So, because we didn't have the internet back in those days. So what would happen is if, you know, Brown and Root or Russ wanted to, you know, buy a CAD system, they would send a team to the AE Systems show, wherever it was, Chicago, Anaheim, whatever. And then within the first hour of the trade show, you would figure out which companies were in play, because they would rotate from the Integraph booth to the Calma booth to your booth, blah, 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 you know. And so you'd see which, you know, typically there would be 3 or 4 big buying teams. And so those would be the big procurements, you know, for that particular session. And then as AE Systems kind of went down, this Daratech kind of emerged. I joked that Daratech started with my Rolodex file, you know, from a lot of these Asian companies that I worked with. There was this guy, Charles Foundier, who started it. This is they were out of Cambridge, Massachusetts. They were kind of a high-end consultant, and then they would do this big trade show at I think it was in January, or yeah, it was like in the winter that they would do every year. And it became specific, you know, for plant design and, you know, plant design. And they had a large international, you know, component to it. So I don't know what happened with Daratech, but that was a big deal. So what happened?
Think pay to play. Think pay to play.
Exactly. Yeah. Exactly. Yeah. So finally, the 3D use case begins to emerge, right? So something that couldn't be done now is being done. And so your primary vendors are Integraph, CAD Center, Combustion Engineering Pace, and then to a lesser extent, IBM CATIA, you know, CADM CATIA. They can never figure out where one ended and one began, you know, CATIA, CADM. But so you have the first reliable 3D modeling systems. You have realistic cost justification, and the cost justification, you know, reduction in total install cost due to clash detection, and then the automatic production of the isometrics. You know, that was a big labor savings. You know, and then now you start to see integrated analysis of the geometry. So Caesar. You have Caesar analysis interfaces, so you can generate the geometry in Integraph or CAD Center and then analyze it in Caesar. And then also on the structural side, Strudel, you could do structural analysis based on the geometry that you've established in your CAD model. But, you know, another recurring theme is that there's a lot of skepticism that, you know, these products would work or not. So this is an ad, I think, that, you know, we couldn't afford, you know, 3-color ads. So 3-color ads was the most expensive type of ad. So you could do a 2-color, black and white and red. All right. So this is, we put this like in chemical engineering or chemical week. And it's like, Not on my job, thank you. And believe it or not, I would get calls from VPs of engineering, direct calls from the VP of engineering saying, yeah, that's exactly what I say. Not on my job. You're not going to do that. Subject me to this 3D crap on my job, you know. So that was actually a very, very effective ad.
Well, Rick,
yeah,
the best way to think of 3D CAD at that time is a design checking, because the business case was you design it, you put it into PDMS, you put it into PACE, and it would do all these additional checks, you know, class checking, which we do visually now, class checking, automatic material takeoff. You know, the business case was total rework reduction in the field. So the best way to think of it at the time was a checking tool.
Right. So I call the English word for custom is bespoke. You know, you have bespoke software, which is custom software, or bespoke tailor, you know, as a handmade suit. And so PACE was sort of a bespoke joint venture between ICI, Dow Chemical, and Duke Power. And so I think ICI had developed the ProView software, which was very similar to PDMS. There was a settlement at some point. I don't know. We never knew what happened, but there was a legal settlement between PDMS and ICI over the ProView system. And I think ICI just said, like, why are we as a chemical company, you know, developing all this software? Like, how do we get rid of it, type of thing. And then so Dow it's like, hey, we can, you know, have a front row seat, you know, on a new system. And then Duke Power, you know, they got involved. They had a couple of nuclear plants that they were working on. This is the era of what I call peak workflow analysis. One of the things I sent in that box is the initial Zydex paper. You know, Zydex was, I think they were also part of the whole PDMS contractor ecosystem, and they did the whole, you know, analysis of how to reformulate the PDS system for Intergraph. And then our friend Mike Leasley went on to burn up $40 million of Autotrol's money on the Leasley project in Austin, Texas, you know, to come up with the next great plant design system. And so one of the things that's in that box is the Duke workflow analysis, where they analyzed, you know, all the construction and engineering activities involved in it, you know, in a power plant. And when I was at Bechtel, we had one of these projects where we took an empty floor, we put every single drawing on the wall. At the time, there was something called Jordan analysis, which was very, very popular, where you would do these data flow diagrams and you draw these bubbles, and you get senior execs to come up and like draw all these specific diagrams, how information flowed, you know, through the organization and stuff. So a lot of these companies were, you know, looking at their operations and saying, hey, how do I put this in a bag? You know, how do I put this on a computer system? So the ProView was the 3D modeling application for PACE. And then we used Schema, which was Jim Merry. He was involved in the PEG system, which was the CAD Center intelligent schematic system. And then you brought up the ghost of Pat Hanratty, MCS Anvil. So Impel, which was a combustion engineering company, they got one of those Anvil licenses. So that was kind of like you would do 3D modeling in ProView, and then to do your annotation and your dimensioning of the orthos, we would use the MCS Anvil tool to do that. And then we were smart enough to figure out that we could, you know, a lot of these companies were like Dow loved MicroStation. And this is back when the Bentley brothers were just the Bentley brothers. And like you would call and you would get Keith or one of those guys on the phone, you know. So we actually developed a MicroStation option where you could do the annotation in MicroStation. But to believe it or not, we would have the software on the VAX. So the 3D modeling software would operate on the VAX. And then we had an IBM PC with the user interface, because the big thing about the big knock on PDMS was that the user interface was difficult to use. You had to do a lot of typing. You know, it was like command driven. So we actually made a menu on the PC that you could drive the 3D modeling system from the PC. So it was pretty wild. And at that time, the marketing strategy of the companies was to try to get the plant owners to specify which system that you would use. And so they would work in concert with key engineering stakeholders. So Intergraph was very tight with MW Kellogg and Rust. And they would try to get them to say, hey, mobile, you should demand that use Intergraph on this PDS on this project. The problem was that these owner operators, they didn't have the sophistication or the need to use these 3D systems. It didn't give them much at the end of the day, you know. But that was the thinking at the time. So PDMS, you know, they worked with John Brown and McDermott. Pace, we had Lummus Crest in Houston. We had H.A. Simons in the pulp and paper industry up in Vancouver area. And then Stone & Webster was the big CATIA reference site for IBM. So the thing that was the breakthrough that we had at Pace was what I call the Korean ethylene war. There was all these big engineering companies in Korea that were trying to build ethylene plants all over the place. And the two largest intellectual property vendors were Kellogg. They had an ethylene process, and Lummus had an ethylene process. And we had a guy, Dr. Muhan, who was a PhD engineer, and he had very good, what the Koreans called kaboon, a good feeling with the Korean companies. And so we were able to win from like 87, 89, you know, basically the whole Korean infrastructure, Samsung, Lucky Engineering, Daelim, all of them. So that kind of put Pace on the map. And these were very grueling benchmarks. I mean, you're talking 2 weeks worth of study. So this is the benchmark team that we used on some of these very grueling procurements. And at the time, the Chaebol, the salarymen at the Chaebol, they would all have like the little pin, the Daewoo pin or the Daelim pin. So my admin, she got this great idea to take a pin and put a map of Korea with Pace on it. And so these things, they loved it. They loved these things. They wear the Pace pins on their lapels of their coats. Yeah. So the other thing that came through in this period is the dedicated walkthrough. So this is, believe it or not, this is a Silicon Graphics machine, the Silicon Graphics Iris. I used to have to rent an Econoline van with a hospital gurney, and you'd pull this thing on. It was like taking a dead body out of the back. It must have weighed 500 pounds. And you'd like, you know, you'd bring this into, you'd like wheel this into Litwin, you know, into Houston, you know, and put this out. But I'll never forget, we were at a trade show, and one of the sales reps is like, he goes, watch this. It's like fishing. And he's got the mouse, and like he's moving the plant around, and like you can see people coming from across the trade show floor. They're so attracted by moving through this plant. And CAD Center, they had a whole dedicated thing, you know, especially in the offshore industry. They had like a whole room. They had a whole office just doing, you know, life-size, you know, plant walkthroughs. This was a very, very big deal in like the mid 80s, you know, the walkthrough capability. But it was all done through this specialized hardware, like the Silicon Graphics hardware. Okay, so let's shift gears into the AutoCAD era, which is, I'll mark it as 1990 to 2005. So this is very, very different. So AutoCAD was sold through independent dealers, okay? So these dealers, they, not in addition to AutoCAD, which had $2,000 at the time, they sold high-end graphics cards. They sold plotters. The plotter might have been $10,000, you know. They did networking. They did training. And so what happened is like a $2,000, you know, copy of AutoCAD is driving $50,000 worth of hardware and networking and services and this type of stuff. So what happens is that the MSRP of AutoCAD pretty soon goes right down to dealer costs, you know, because they're selling, you know, all sorts of stuff besides the AutoCAD. The AutoCAD makes it happen, right? And then, so this is the first list of dealers that we had, you know, back, you would fax them in those days. That's how you communicate with them, via fax. And from a pricing standpoint, they made a decision that there'd be no hardware lock. You used to put this hardware lock on the parallel port, the LPT1 parallel port of your printer. And that's how you controlled for piracy. So there was no hardware lock in North America. And the enforcement was basically through, shaming people through the Business Software Alliance. And they also had an academic license program where you could get an academic license for like $500. And so this created a lot of other product leakage. I mean, it was brilliant in the sense that this is how Autodesk got on everybody's desk, And so what you had is virtually a major piracy problem, especially internationally. There was no illegal AutoCAD overseas, And from a competitive standpoint, there were a couple of things. There was a product called CADvance, which went nowhere. Visio for a while was a big deal. And then MicroStation came along, Bentley came along with this clone of the IGDS Intergraph system. And so, Intergraph, filed lawsuits, and then their legal remedy was, well, hey, we're going to become the exclusive reseller. So basically all the MicroStation was sold through Intergraph, and this became, an Intergraph issue. And so they did not have a dealer channel, so to speak, a very, very minor dealer channel. And during this time, Intergraph basically is becoming a plant design company. So in 1999, PDS was their largest software offering, it was 30% of their sales. So the rest of it was just MicroStation and hardware. So basically they were on the same plane as PDMS. They were pretty much a dedicated plant design company during this period. And so the other breakthrough that Autodesk had is that they had the third-party application development program. So this is an ecosystem based around AutoCAD. So unlike DEC, an ecosystem based around the VAX, this is an ecosystem based around the AutoCAD software. So their focus at the time, it was still a developing product. It couldn't do everything. So they were focused on the core graphics engine of AutoCAD, and they were neutral on application development. So they gave us things like AutoLisp, which was pretty weak, but you could develop things with it and other tools. From a plant design standpoint, the two breakthrough things that we needed was AutoShade to do rendering, and then hidden line generation, because you couldn't do certain types of drawings like orthos and stuff without hidden line. And so, as I showed in the past slide, with the MSRP going to dealer cost, this is a great way to boost dealer margins. So what you'll see, these dealers, basically they became Sofdesk dealers. Sofdesk was the architectural product that was, what was it? DSA, Dave something, the owner's initials, and then they changed the name to Sofdesk, which is architectural application.
If I could interrupt.
Yes, please.
The thing that struck me when I first was introduced to AutoCAD, right away I knew that computer vision for schematics was dead. Okay, the very first time I saw it, I knew right away that it was over for schematics. But Autodesk's big vulnerability was it was a 2D drafting product, not 3D, 2D. 2D, the third dimension was like a non-graphic property for them. It's like where you are in 3D. But 2D wise, it was a killer for schematics. And, PFDs, PNIDs, any schematic, it was over. No more computer vision for that. It was just so obvious. But go ahead.
Yeah. PNID was one of the first use cases for AutoCAD. It was one of the first ones created on AutoCAD. Yeah. So they would have a conference called CAD Camp. We'd all go to CAD Camp at the Autodesk headquarters in Novato. And, they had the Autodesk resource guide. So it had over 1,000 applications, many regional solutions, so like it would do the same thing, but it would do it in, like in the Spanish language or the French language or something else like that. So in the plant design space, there were three primary vendors. The first one was a company out of Calgary, Alberta called CAD Pipe, Indigo Systems. And they did Canadian oil sands stuff. Probably they worked on the Syncrude job or something else like that. And they had the CAD Pipe PNID, CAD Pipe Ortho, CAD Pipe Isometrics. So the isometrics, they had an isometric grid. So you drew on an isometric plane and stuff. So it was manually drafting the isometric. ADEV at Metairie, Louisiana, these guys were McDermott IT guys, and they had big system PDMS type experience at McDermott, and they came up with the ProPipe, P&ID, ortho, and isometrics. They owned the state of Texas and Louisiana. I mean, it's like, it was all over. It was under every rock, ProPipe. And they had, I'll call it innovative. We used to joke about it, but they had the 2.5D. So at that time, it's like 3D doesn't work. So you would do the plot plan, and then on the side you would do the vertical, and then you would take the vertical and then you kind of drop it in there to create like a 3D component and stuff like that. It's kind of Rube Goldberg, but it was innovative. It was innovative, And they also were smart. They came up with the the OmniPipe, the microstation version, which increased their market share. So I worked at EDA in Berkeley. We were kind of the eggheads of the business. So we had been a CAD pipe dealer, and we had been PACE subcontractors. So we had 3 analysis programs that were part of the PACE system. The owners were, PhDs in structural engineering from Cal, smart guys, came up with the Autoplant P&ID designer and isometrics program. We actually bought the products from a guy in Louisiana who developed it, Renzo Spanhoff. So we were late entries, so like, and we were doing 3D modeling. People couldn't, once again, you can't do 3D, especially in AutoCAD, right? 3D is hard enough, but to do it on AutoCAD is impossible. And so our approach was to offer these VAC system features for AutoCAD. So we had integration for pipe stress. We work with the guy from Bechtel, Buddy Cleveland. Buddy Cleveland started a company called Jacobs, and they had clash detection. So we were the first to integrate the clash detection into an AutoCAD framework. And then we worked. So after ICI, unloaded their software onto PACE, they unloaded their people, John Lyles, in this company called Alias. So they spun these guys off. So Alias now would independently license Isogen to all these people. And so we work with Alias to license the Isogen product. Sorry, I've been a cough here. So because we were late to the game and we couldn't sell in Texas and Louisiana, our strategy was go where they ain't. So 50% of our sales were outside of the US. And some of the things that we did is we focused heavily on metric support. We had tutorials in metric, and we had a German version. We had DIN pipe specs. We had a very close relationship with the Japanese distributor, CRC. This is me with the JGC Martian. JGC is a big engineering company in Yokohama, and they had an ad campaign that when we build plants on Mars, JGC will be there. So there's a Martian in their office. And we invested heavily in like what they called at the time double byte characters, so that you could put kanji, and you could have kanji menus and Chinese character menus and this sort of stuff. And we opened up offices in the UK. We had a guy in Taiwan. We had a guy in Mexico City. And so we really focused on international sales. And then we had specialized resellers, because pipe specs, it's hard to figure this stuff out. And so we would get small engineering companies or equipment suppliers, and they weren't really focused on AutoCAD or hardware so much, but they were in the business. So like we worked with, back in the day, I mean, there were 2 wonderful engineering companies in Caracas, in Electra and Jantessa. I mean, they were as skilled as any American or Canadian engineering company. All that went to hell with, the socialism there and stuff like that. But so we would hire guys like that, and they would form small divisions, and we could put them all through Latin America and to help us sell the product and stuff like that. So that put us at odds with AutoCAD, because we weren't selling lots of AutoCAD. That wasn't our focus. Our focus was to sell our software. If they were to buy, AutoCAD on the side, that would be great. As a matter of fact, I sold the first legal copy of AutoCAD in China to one of our customers, CNOOC. Yeah, first legal copy. That was like a milestone. So our breakthrough client was Lucky Engineering. And so we used to joke that the software works, but it only works in Korea. So Lucky did the first large scale 3D project in AutoCAD. This is S.J. Kim. He went on to be the CIO of Lucky Engineering, and I took the president of EDA to Korea, and we sat down in the Lucky offices. There was a guy, the VP. No, the chairman of the company was a guy, they called him Heavy Mouth, Chan Min Park, Heavy Mouth, because he never smiled. And we're sitting down in these little chairs, and Mr. Park goes, Mr. Carell, I see you have a new plant engineering system that you're selling. Perhaps you'd like to buy back the one you sold us last year. And I'm like humming, and I go, well, this is different. It works in AutoCAD. It's something that you could sell to your subcontractors, and we could make you a distributor. And he says, good idea. So this roll of I don't know if you can see this roll of drawings over here in the corner. Okay. But this was evidence. So this roll of drawings went around the world at least 10 times. Anytime we had like a big procurement anywhere, it would be like, hey, give me the Lucky Engineering drawings. And I'd put them in a tube and I'd send it, to wherever it went, So this is the most well-traveled set of drawings that you'd ever see, And so that was our breakthrough client. And so some of the success factors I think that we had was what I remember being, when I was with Pace, we were in Mexico City. We were going to do this big demo to Pemex. And so you get a loaner VAX, and you get a TK50 tape drive, hate those things, and I'm there and I'm trying to load this software and I'm into it like an hour and a half. And all of a sudden, boom, the power goes out and I start again. 3 days it took me to install that software, just especially if you had like power issues and stuff like that. So I remember one of the sales managers going, we need to make this software easier to evaluate. And so one of the brilliant things this guy Renzo did is he had a demo system that had you could do anything you wanted with 1, 4, and 6-inch pipe. And we used to joke that there's whole plants built in China with 1, 4, and 6-inch pipe. That's it, but you could evaluate it, because people didn't believe that you could do this work 3D in AutoCAD, so here you could do it. So we would send these little 5-inch floppy disks. That's what it was. We'd send it out there and we get faxes back with all these big giant refinery drawings, it's like, okay, we'll buy it so that we can put in 8-inch pipe, And we had a lot of videos and slideshows. And then another thing that we did is, once again, common theme. You got to overcome the user skepticism. I mean, it's 10 years of my life of trying to overcome the user skepticism. You can't do that with AutoCAD. So one of the things we did is I hired this guy, Jerry Fireman. He was, how do I say it? A hack journalist. I guess that's the simplest way to say it. And what he would do is he would monitor all the editorial calendars of all these magazines. They always need content, he says, And so he'd wait, like, March of next year is the piping issue. And like, he would give him an article. And so what I'd do is whenever we would sell a system, like this guy, Dane Korn, we'd have Jerry Fireman call him up. He'd write something up. He'd mention Autoplant 3 times in the article, and stuff like that. And then he would get this placed in like 3 magazines around the world, And so the customers love this because they're famous. It's like, wow, look, you got my name in a magazine article. And they became very, very loyal. And then when they go someplace else, they'd buy the product again, And so we had this whole, ecosystem of guys that were getting their names written up, for success stories and that sort of stuff. And I always carried a portfolio of evidence, always had, drawings with title blocks, Fluor title block, Bechtel title block, whatever, PMX title block. Because the thing that you have to do is you have to overcome the theta angle. I can't tell you the number of times that I've been in the office and the client points up, he goes, yep, your software doesn't work. You see, there's the software right up there on the shelf. It doesn't work, And I'd say, hey, I'd bring out the evidence and I'd say, well, it's working here. It's working here. It's working here. What do you think the problem is? Humidity? You know, maybe too humid in here. I say, look, it's counterintuitive, but you know how you want to get that software to work? You got to buy 2 more copies. And you put 2 more copies up at the shelf, and the shelf will deflect until it overcomes the angle theta, and it'll magically start working. Because what happens is that the first guy didn't read the manual, the second guy didn't read the manual, the third guy reads the manual, and then he teaches the other 2 guys how to use the software. So when I was going through China, I would make the guys sleep on the manual. I would make them sleep with the manual under the pillow, so it like transmit into their head, you know, while they were sleeping. So to finalize the situation, so the market started to consolidate in the mid 90s. So this DCA, David C. Arnold, he was out of Henniker, New Hampshire. He was the architect. He developed the DCA software, which became Sofdesk. So if you can believe this is before Sarbanes-Oxley and all that stuff. Here's a company that just did a initial public offering. They didn't even have their own graphics engine. You know, they were just an add-on to Autodesk. I mean, this is unbelievable. They had an IPO in 1994. And then so in 1994, Autodesk said, hey, look, you know, we need to scale you up. So they gave $5 million so that we would merge with ADEV. And we became a product called Rebus. And in 95, we became the Inc. 500. I don't know if that's still a thing, Inc. 500, but that was a big deal. If you were a fast-growing company, you got into the Inc. 500. And then there was a Sofdesk competitor in 1995 called Eagle Point. They were out of Iowa, and they had an architectural product, and they went public. So you had 2 developers, Autodesk developers, go public in 2 years. So in 96, Autodesk kind of switches gears and they acquire Sofdesk. And this pretty much kills the developer channel because, you know, Autodesk was not competing with us all this time. So now they're in direct competition with every other architectural third-party developer, you know, and that just starts to grow. So by 99, you know, Rebus became a major competitor to Intergraph and CAD Center. Actually, we had more users than anybody. We had about 85,000 users. And we were in a lot of the big owner operators because we were easy enough to use. You know, PMX and Suncor, these guys could use it. 2000, the .com crash happens. No IPOs. Autodesk says, "I'm done with this plant design vertical. You figure it out on your own." Eagle Point actually goes private because they can't compete anymore. And then 2002, Rebus gets acquired by Bentley, and that's pretty much the end of the independent AutoCAD-based plant design software companies. So, as I say, the technology impacted my lifetime. You know, when I started in 1980, draftsmen were doing 85% of the P&IDs, maybe a little bit on CAD, 15%. Now it's all 100% on CAD. Plastic model, every big project had one. Now, 3D model, 3D digital model it's once impossible. Now it's standard procedure. And the plot plans, once again, 95% were done by hand. I don't think you need them anymore. You know, why would you need them? Or you plot a layer. You know, the 3D model is there. You don't need a specific plot plan to tell the model, the plastic model maker what to do. So you've eliminated a whole class of drawings. The orthographics, 100% done by draftsmen. You know, now it's an annotation byproduct of the model. You know, it's a very minor effort just to add dimensions on things, reference dimensions, reduces the budget probably by 25%. Isometrics, that was 90% done by draftsmen, maybe 10% on systems like Screen. You know, now if it's a big project, they're automatically generated by Isogen or manually drawn on a small project with an isometric CAD grid. The automation of the MTO is complete. You've reduced the budget another, 20, 30%. And I did some, I looked at some invoices. So we would buy a computer vision 5-system CAD system, 5 users, was $90,000 a seat. $90,000 a seat. That's $342,000 in today's money, if you can believe that. So like now, 5K will get you that, today. And that's pretty much, that was my story of 3D plant design.
Well, thank you, Rick. That was very interesting.
That's very, very interesting.
Yeah, it's very cool to see it from that side, Rick. I pulled up an old CV of mine, and I'm looking at all these products that I used on the on the engineering side, and then you're on the development end, and it's like, oh yeah, okay, I see that date, I see that date, I see that date, and we switch to this, and we switch to that, and we switch to that. It's really neat to hear that story.
Well, your impact timeline really brings out a sea change, and that is this transition to use of the model as the data of record. It's not, as I made the comment during your talk about, we used to enter the data in PACE and PDMS as a design check, and now it is the data of record for all these other rendered, generated things like isometrics, like plot plans. It's now considered the data of record. And only the very smallest projects will treat it as if it's a drafting tool. Sometimes a legacy rework, you get involved in real drafting. So the other thing that was going on in the background that I might comment on in go back to the computer vision days, we were happy at 16-bit computers. We thought that was a thrill. In fact, to get a hard drive, that was a thrill. Okay, to be able to store stuff in a hard drive. You remember when CPM came out, and you finally got a portable terminal that had an internal hard drive. I remember my business partner looking at a floppy drive and said, "What's that for?" Okay, so now we have 64-bit computers on our cell phone. Okay, we're some people are doing 3D photogrammetry using their cell phone as the basic scanning tool. I mean, it's amazing how much the technology has changed. I remember I did a presentation, which was a trial balloon of our training material, our error checking material at E&I, C&I engineering. And I said, we're going to use CAD. We need to teach them about automatic flash detection. And they said, what? We don't do that anymore. It's so easy to rotate the model in our private terminal that we can spot clashes visually faster than we can run a software tool. So even the platforms themselves, the hardware platforms, have changed the paradigm completely. It's just amazing what the support is. And now we're looking at artificial intelligence, which I think is going to have a major role to play, if not in design rule checking, but maybe automatic generation of things. I don't know how that's going to work exactly, but the vendors themselves and the users have made explicit a lot of their design rules. A lot of their content is now explicitly known. And I think that's going to eventually be loaded in, not eventually, but very soon loaded in an AI system. And we'll see a lot of either rule checking, design checking, or even generation of designs itself for visual inspection, like an auto router. Auto routers I thought was a side novelty for years. And now it seems to be, I can get at least two commercially available auto routers that are pretty decent. They're pretty. You get a pretty decent estimate of what the cost of the plant's going to be. So and then automatic ortho rendering software. I didn't think that would ever be possible, but like Isogen, you can render orthographics automatically. It's amazing how the platform and the automation tools have followed along. And my final comment is that SPED has worked with the idea that designers are a profession all to itself. There's an engineer, piping engineer, and there's a piping designer. But the piping designer is becoming more of a power user. You know, he's the guy who manages where the data is. He's the guy who understands the problems in error checking. He's the guy that repurposes data either through rendering or even deliveries to the client, different systems. He's become a Superman, okay? And so we don't have a dying profession, we have a consolidating profession, but the barrier to entry is very steep now because you have to know so many things. But anyway, I think, you know, this is so nostalgic, all these things you talked about, all these players, you know, Leasley and Malcolm Hall and all these pioneers that we bled for this stuff. You know, we bled during it. Let's put it that way. It was very difficult to get this stuff to be profitable. I remember at Brown and Root, we would turn out isometrics, and we were glad to get an isometric out in 40 man hours. And then some guy in his garage would be turning them out in 30 man hours. So we would find a way to get them down to 30 man hours. Now he was bidding 20 man hours out of his garage. We would get it down to 20 man hours in ISO. And finally, you know, he could knock it out in 15. And I don't know. It was just a never-ending battle with people that could do it faster than CAD. And now the reverse is true. CAD is much faster than any manual process for most plants. I wouldn't say all plants, but most plants. So very nostalgic. Thank you very much.
Awesome. Well, thanks for taking my historical document.
Yeah, we took the guilt away of throwing it out, so we didn't. You don't have.
I couldn't live with myself if I threw that stuff out. Yeah.
Okay, thanks again, Rick. Thank you for putting together a nice
Thank you very much.
Very cool.
Wonderful.